Hi students, today we are going to discuss the topic particle-like nature of electromagnetic radiation from structure of atom. Now in the last video I discussed about the wave-like nature of electromagnetic radiation, right? That wave theory could able to explain many phenomena like refraction, interference, reflection, etc. But the same theory could not able to explain the phenomena like black body radiation, that is nature of emission of radiation from hot bodies, photoelectric effect, ejection of electron from metal surface when radiation strike on it, and line spectra of atoms with spatial reference to hydrogen. Now in order to explain this phenomena, okay, so Max Planck in 1900 proposed a theory called Planck's quantum theory, and this theory was further extended by Einstein in the year 1905. Now let us discuss the main postulates of Planck quantum theory. Now the main postulates are: the energy emitted or absorbed is not continuously but discontinuously in form of small discrete packets of energy. So according to Maxwell, what we can say is, if the radiation is a wave-like nature, right? So that means it will emit it in the continuous form. Okay, but now according to Planck quantum theory, so this energy is not absorbed or radiated in continuous form but discontinuously in form of packets, discrete packet, and each packet is what called quantum. So this is your quantum. Okay, now in case of light, this quantum is called photons. The next is, so this whole like quantum in plural form we can write is a quanta. Now second is, the energy of each quantum is directly proportional to frequency. Now this quantum, okay, its energy will be proportional to frequency, and whenever proportionality sign is removed, we need to introduce is the constant term, right? So here the constant term is h, and this is what called Planck's constant, and its value is every time constant, and it is equal to 6.626 into 10 to the power minus 34 joule second. Now third postulate: the total energy emitted or absorbed by a body will be in whole number quanta. So that means your total E will be integral multiple, okay, of your h nu. So where n is your whole number 1, 2, 3, 4. Okay, so n can never be fractional value. So it is every time a whole number. So for this region, what we can say, this is also called your quantization of energy. So the Planck quantum theory, okay, gives the relationship between energy and frequency of the radiation by the formula E equal to h nu. Now let us solve one numerical from the same topic. Calculate the energy of 1 mole of photons of radiation whose frequency is 5 into 10 to the power 14 hertz. So what is given here? Frequency, so which is equal to 5 into 10 to the power 14, and you are asked to calculate energy, okay, for 1 mole of photons. Okay. Now according to Planck's quantum theory, okay, so we can calculate energy of one photon, right? So E, energy of one photon, and how can we calculate? It is equal to E equal to h nu. What is h? Your Planck's constant, and its value is 6.626 into 10 to the power minus 34 joule second. Okay, now substitute the value here. So we'll get, so h is 6.626 into 10 to the power minus 34, right, into, and nu 5 into 10 to the power 14, right, hertz. So after calculation kati pauncha? So 633 So we'll get 33.130 into 10 to the power minus 20 joule, or we can write it as 3.31, okay, into 10 to the power minus 19 joule. And what we are asked to calculate? Energy of 1 mole of photon. So energy of 1 photon is 3.31 into 10 to the power minus 19. So what would be the energy for 1 mole of photon? 1 mole भनेपछि कतिवटा हुन्छ? Avogadro number, right? So what you have to do is you have to multiply this value with Avogadro number. So 3.31 into 10 to the power minus 19 into Avogadro number 6.022 into 10 to the power 23. So answer हुन्छ तिमीहरुको 19.92 into 10 to the power 4, right? And unit हुन्छ energy को joule. So 3 गर्यो भने के हुन्छ? So 3 बनाउनुको लागि 0 will come here, right? So 190.92 into 10 to the power 3 joule. So 10 to the power 3 भने बित्तिकै it's a kilojoule, right? So answer हुन्छ 190.92 in kilojoule, mole inverse. So energy for 1 mole of photon is equal to 190.92 in kilojoule mole inverse. Topic is black body radiation. Now what is black body? So it is body which absorbs radiation of all frequencies. So anybody absorbs, okay, or emit radiations of wide range of wavelength, and is called black body, and the radiation which is emitted or absorbed by black body is black body radiation. So now according to Max wave theory, okay, on heating a body, the intensity of the radiation should increase without affecting the frequency or wavelength of the body, okay. But it is observed, हामीलाई यादै छ हैन, whenever we heat iron rod के हुन्छ? So what we observe is like first ma iron become red, it become more and more red, हैन, bright red हुन्छ, then finally it will change to yellow, white, र at the end we'll see the change in color blue, okay. Now यता के हुँदैछ भन्दाखेरि, so as we have already discussed, right? So this white, red, blue, it's in the visible region, हैन, VIBGYOR. Now यहाँ के हुँदैछ? Now your color is changing from red to blue, right? So color change हुँदैछ भन्नुको मतलब wavelength is also changing. How it is shifting to the lower side, right? Lower value. So red को lower value मा के हुँदैछ? Change हुँदैछ. So that's 750 day 380, right? So तिम्रो wavelength change हुँदैछ. Frequency like wavelength decrease हुँदैछ, your frequency increase हुँदैछ, हैन? So यता के भयो भन्दाखेरि Maxwell ले के भन्यो? Again I have already told you, like heat गर्दाखेरि तिम्रो खाली के हुनु पर्यो? Intensity increase हुनु पर्ने थियो, okay. That means red थियो भने अझ bright red हुँदै जानु पर्ने थियो, but at the end what we can see is like change in the color, हैन? भनेपछि तिम्रो frequency, your wavelength is also changing. So भनेपछि so your Maxwell wave theory is not 100% true, हैन? Again if we see the change, हैन, variation of intensity to the wavelength, so graphically, so this is what you get. Now from here what we can say is like the wavelength, हैन, the radiation having very low wavelength or very high wavelength, हैन, तिनीहरुको intensity के हुन्छ? एकदमै कम्ती हुन्छ, र this peak, so this is the wavelength, हैन. So the lambda max पनि भन्छ यसलाई. So this is the wavelength whose intensity is very high, and because of this के गर्छ तिमीले, we see the color. अब कुनै पनि object को, okay, like green leaves, why it appear green? किनभने whenever so absorb गरेर it emit radiation, right? र अब त्यति बेला के हुन्छ भन्दाखेरि green light को, okay, intensity will be maximum, and for that reason that green leaves appear green. So त्यसरी नै now, so if we see the change in temperature, now variation, what is happening to the wavelength? So see, it is shifting, right, to the lower value. So whenever just 300, 3000, 4000, 5000, 6000, हामीले temperature increase गर्दा के हुँदैछ भन्दाखेरि तिम्रो lambda max जुन चाहिँ छ, that is shifting to the lower value. So भन्नुको मतलब अब your यता wave theory के हुँदैछ? यता fail हुँदैछ. So here what is happening is so whenever तिम्रो के हुँदैछ your energy is dependent on frequency. So if you increase the energy, then के हुँदैछ तिम्रो frequency हैन heat जति तिमीले increase गर्दैछौ then त्यति नै frequency of the radiation is changing. Okay, so for that region you can see the change in color. So यता के हुँदैछ lambda max घट्दैछ मतलब के हो तिम्रो frequency बढ्दैछ या energy बढ्दैछ. So next is the photoelectric effect. Now photoelectric effect के भन्दाखेरि so when radiation, right, with a certain minimum frequency nu naught, so threshold frequency पनि भन्छ, so strikes on the surface of the metal, then what happen is electron eject huncha. Okay, electron eject from the surface of the metal, and this phenomena is what called photoelectric effect. Emitted electrons लाई भन्छ photoelectrons. Again, तिम्रो radiation of certain minimum frequency, whenever it strikes on the metal surface, then electrons on the metal surface will get ejected. Okay, and this phenomena is the photoelectric effect, and the electron emitted is photoelectrons. In 1887 at Hersley, he performed experiment in electrons. Okay, what he did is he exposed beam of light on metal, potassium, rubidium, cesium, okay, as shown in the below, and either the ejected electrons are counted by a detector measure. Okay, that measures their kinetic energy. Now through this experiment various observations were made. Number one were the electrons are ejected from the metal surface as soon as the beam of light hit the surface. So hit गर्ने बित्तिकै there is ejection of electron without any time lag. And number two मा थियो the number of electrons ejected is proportional to the intensity of the light. Okay? So whatever the more the intensity of the light, more were the number of electrons ejected. Okay, number third point ma for each metal there is minimum frequency threshold सबै frequency हुन्छ threshold frequency हुन्छ. That means or what we can say is electron, okay, is binded to a surface हैन. त्यो के हुन्छ सबैको आफ्नो आफ्नो binding energy हुन्छ. Some metals मा electrons are strongly binded, or in some metals they are loosely bound, right? So what so we have already studied हैन the variation in the atomic size or ionization energy. So larger the atomic size, lower will be the ionization energy. त्यसले गर्दा photo यो जुन चाहिँ electric effect मा usually we use the metal like potassium, rubidium, cesium, which will have large atomic size or will have the low ionization enthalpy. र सबै metal को के हुन्छ भन्दाखेरि चाहिँ there is a minimum frequency required हैन in order to remove the electron, below which तिम्रो के हुँदैन photo ejection हुँदैन. Suppose तिम्रो metals, suppose it is bind to the surface with a certain energy, let's say 5 kilojoule energy ले bind गरेर बसेको छ. If you are providing energy हैन, so just the 4 kilojoule तिमीले प्रोवाइड गर्दैछ, or the photon जुन चाहिँ radiation छ त्यसको energy 4 kilojoule छ भने will the ejection occur? No. Why? Because this energy of radiation will not able to overcome the binding force, or बुझ्यो, त्यसले गर्दाखेरि चाहिँ ejection is not possible. So minimum हुनै पर्छ, like 5 हुनु पर्छ, 5 kilojoule या 4.9 छ भने पनि the ejection will not occur. तिम्रो 5 हुनु पर्छ या 5 भन्दा ज्यादा छ भने पनि ejection will occur with certain kinetic energy. Now when frequency, अब जुन चाहिँ frequency of your photon है, जब frequency if it is greater than your threshold frequency, then the ejected electron will not only eject but it will come out with certain kinetic energy. Now the kinetic energy of electrons which are emitted, right, it is directly proportional to the frequency. अब तिम्रो photon को frequency जति बेसी हुन्छ त्यति बेसी speed मा the electron will move, and is quite independent of their intensity. Like तिम्रो electron जुन चाहिँ ejected electron छ, once you eject भएपछि त्यसको kinetic energy will not depend on the intensity, rather it depends on the frequency. So these were the observation made by made during experiment भयो. So light आयो, certain energy हैन, so तिम्रो energy सपोज मिनिमम एनर्जी और मिनिमम फ्रिक्वेन्सी यसलाई हामीले भन्छ थ्रेसोल्ड फ्रिक्वेन्सी राइट हुनै पर्छ देन ई नट लाई हामीले भन्छ थ्रेसोल्ड एनर्जी okay or work function we call it as work function also. Now when your energy of photon तिम्रो इक्वल्स हुन्छ थ्रेसोल्ड एनर्जी देन इजेक्सन विल अकर भयो इफ तिम्रो एनर्जी अफ फोटोन बेसी छ भने अब के एउटा त हेल्प गर्यो इजेक्ट भयो अब तिम्रो 5 किलो जुल छ अब 6 किलो जुल सपोज तिमीले अब हिट गर्दैछौ राइट 6 किलो जुलले हिट गर्दैछौ अब 5 किलो जुल त युज्ड अप भइहाल्यो बाइन्डिङ एनर्जी ओभरकम गर्नुको लागि राइट सो 1 किलो जुल उब्रिन्छ राइट नाउ दिस 1 किलो जुल त वेस्ट हुँदैन बिकज अर लस हुँदैन एज बिकज वी नो द्याट एनर्जी क्यान निदर बी क्रिएटेड नट डेस्ट्रोइड राइट रादर इट transform into some other energy. So here your 1 kilojoule will now convert to kinetic energy. Right? So E is equal to what we can write is E is equal to E naught. So energy of photon will help the electron to knock out. The arco will give the kinetic energy to the electron. So this is what called your photoelectric effect. Right? So main E, what is E? E is your h nu. And E naught threshold energy work function, what is it? It is your h nu naught. Okay, and what is kinetic energy? So it is half mv square. In this case, your we are talking about velocity mass of electron. So mev square. Your equation हामीलाई चाहिन्छ. Okay. Now next is like what is the conclusion made, right, after photoelectric effect. So we have already discussed. So if energy of the incident photon is less than the threshold, right, if E is less than E naught, then what will happen? The photo ejection will not occur. Fine. Number 2 ma bhन्छ if h nu is equal to h naught, then what will happen? The electron will just release, right, without any speed. Then third ma bhन्छ if your E is greater than h nu naught, okay, so then your emitted electron will acquire some kinetic energy. So this is all about photoelectric effect and black body radiation. So now let us solve this question numerical, okay, related to photoelectric effect. Light if wavelength 5000 angstrom falls on a metal surface of work function 1.8 electron volt. Find the energy of photons and kinetic energy of photoelectrons. So 1 electron volt is equal to 1.6 into 10 to the power 19 joule. Okay, now what is given? Wavelength, okay, of your photon, which is generally denoted by lambda. So this is equal to 5000 angstrom. Then your work function. So what is work function? It is generally denoted by E naught, right? So this is equal to 1.8 electron volt. Then you are asked to find out energy of photon, that is E equal to how much, and kinetic energy, okay, so you need to find out, okay. So convert this to meter. So we know that 1 angstrom, okay, is equal to 10 to the power minus 10 meter, or you can write this as 5 into 10 to the power minus 7 meter. Okay, sir? Okay. Now first we find out E. So E equal to h nu. So but nu is not given. What is given? Lambda. So what is lambda in terms? What is nu in terms of lambda? It is equal to h c by lambda. Okay, substitute all the values. Now we know that c is your speed of your this electromagnetic radiation, right? So or light, speed of light. So it is equal to 3 into 10 to the power 8 meter per second. Then he gets up, h is constant every time, so 6.6 into 10 to the power minus 34 joule second. And now substitute the value here. So कति पाउँछौ तिमीले? H is 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 5 into 10 to the power 7. Okay. So हाम्रो हुन्छ 6 र 3 मल्टिप्लाई गर्दा it 19.8 into 10 to the power. So यो कति भयो माथि जान्छ ओके -7 सरी -7 15 हुन्छ 15 मा यो घटाउँदाखेरि कति हुन्छ तिम्रो 19 so divided by 5 हेर -19 भयो so you will get answer as 3.4 भनेपछि 45,936 into 10 to the power -19 आउँछ E in joule. Sorry, E in joule. ठिकै छ now next छ E आयो now you are asked to calculate kinetic energy now what equation we know that so E is equal to okay E naught then plus K E so E naught is given Ke you are asked to find so E naught के मा छ तिम्रो electron volt मा छ and your E is in joule so now you need to convert either joule to electron volt or electron volt to joule so it is up to you भयो so हामी यता electron volt लाई will convert it to joule so E naught कति दिएको छ it is equal to E naught is equal to कति छ 1.8 electron volt and 1 electron volt is equal to 1.6 into 10 to the power -19 joule. So when you multiply electron volt convert huncha joule ma. So you will get E naught work function as 2.88 joule. Now Ke ke huncha according to above formula or equation this equation. So now Ke we can write it as E minus E naught. ठिकै छ now E कति छ 3.96 right 10 to the power -19 you open 10 to the power -19 you can take it common minus 2.88 into 10 to the power -19 and joule ma so minus गर्दाखेरि 16 8 मा 80.1.08 into 10 to the power -19 joule so what is your question what you are asked to find out your energy okay of photon and kinetic energy of photoelectron so these are your required answer one question from the topic photoelectric effect in a photoelectric effect experiment irradiation of a metal with light of frequency yield electron right so this is your frequency of photon so E is equal to sorry H is equal to which is so sorry what is frequency generally denoted by nu so this is your frequency of light so nu only 5.2 into 10 to the power 14 hertz or second inverse ठिकै छ then yield kinetic energy so maximum kinetic energy cha kati hundaicha electron eject भयो with certain kinetic energy which is equal to 1.3 into 10 to the power -19 joule okay now what is the question you are asked to calculate nu naught for the metal so what equation we have so we know that right so E is equal to E naught plus H nu. So sorry. E is equal to kinetic energy Ke. Okay. So you need is this not E naught. So Ke then E naught we can write it as E minus Ke. So we have frequency. So first we need to find out what is E. Now E is according to formula it is equal to H nu right so H is 6.62 into 10 to the power -34 right into nu is 5.2 into 10 to the power 14 so kati 34.4 into 10 to the power kati cha -20 okay यहाँ कति छ 19 मा छ, so make this in 19, so we can write this as 3.44 into 10 to the power minus 19 भयो। किन यहाँबाट 10 निस्किन्छ, 10 into 10 to the power 1 minus 20 कति हो 19 right, minus 19, so हाम्रो E पाएको छ 3.44 into 10 to the power minus 19, kinetic energy छ 1.3 into 10 to the power minus 19, these two will we can take it common right, and minus गर्दा कति हुन्छ 2.14 into 10 to the power minus 19, and answer you will get it in joule. So this is your E naught, but you are asked to find out nu, right? So we know that E naught is equal to H nu naught, okay, or nu naught you can write it as 2.14 into 10 to the power minus 19 joule divided by H, and H is 6.6 into 10 to the power minus 34 joule second inverse, right? Joule second. So तिम्रो answer हुन्छ, so you will get यो divide गर्दा यहाँ 0 राखेर यो गर्नु, यो जो जान्छ 214 divided by 660, okay, क्याल्कुलेटरहरु युज गर्नु पाउँदैन, त्यसले गर्दा मल्टिप्लिकेसन डिभिजन घरमै सिक्दै गर्छ है। सो यु विल गेट यति भयो। नाउ यसलाई डेसिमललाई यहाँ ल्याऊ, सो 3.24 into 10 to the power minus 1 हुन्छ, सरी 10 to the power yes minus 1 हुन्छ, र minus 1 plus 15 गर्दा कति हुन्छ 10 to the power 14 second inverse nu naught. This is your threshold frequency or threshold frequency for metal. Underline garcha, and do not forget to write the unit for your answer. Okay, so hope you understood. Thank you all.